Cisco Big Analytics. My name is Chester Chen. I'm one of the organizers. So we have our sponsor AI Camp to provide the Zoom for us. So we have a great talk today. And before I introduce the speaker, so I just gave you like a 10 seconds introduction to our upcoming event. Besides today's talk, and we also have another talk in October by Ryan Blue, who's going to be talking about the Apache Iceberg. So and then after that, we have some kind of a machine learning related to talk on the semantic search and neural information retrieval, so which is in November. So for today, as I said, it's like we have a special talk from. I'm just going to click on this. Well, the meetup is a little slow. So we have a special talk by Nick Shurak, who's the founder and CEO of the Elemental. This is a company who behind the Dagster. So he worked at Facebook and also famously co-created the GraphQL. So as we know, working on the data platform and working orchestrating the different pipelines, that we need a kind of a workflow engines. So Dagster is one of the alternatives. People probably know about Airflow, but there's one of the other engines currently pretty popular. So with that, I'll turn to Nick and I'll tell you all the story about it. I'm gonna stop sharing here. Nick, it's all yours.
Great, thanks. Thanks for that intro. Let me share my screen here. So yeah, thanks for having me. Really excited to speak here today. I'm going to trust that everyone can hear me and see my slides. So I'm just going to go for it. Let me know in the chat if there's any problems. So yeah, as mentioned, my name is Nick Schrock. I'm the founder of Elemental, the company behind Dagster. And, as mentioned also, my kind of bulk of my engineering career was spent at Facebook, where I founded this team called Product Infrastructure. And that team ended up creating React Native, and the thing that I was personally involved with, which is GraphQL. I like to joke that I was present at the creation of the full hipster stack. But I really saw the impact of open source projects and just, how broadly they can be adopted. And it was really exhilarating to be part of that. And, after leaving Facebook in 2017, I took some time to figure out what to do next. And I went around asking both kind of legacy so-called companies, as well as companies in the Valley, about what their biggest problems are in their tech stack. And this idea of data infrastructure, ML infrastructure kept on coming up over and over again. And I looked into it, and what I like to say is that I found the biggest mismatch between the complexity of a problem domain and the tools that support that domain that I've ever seen in my entire career. And I'm just really attracted to problems like that, and just compelled to, in fact. And as I was looking at this ecosystem, it was really orchestration that stuck out to me as a critical point of leverage in companies' data systems. So it's worth stepping back and thinking about what is data orchestration. So when a person or team wants to put a data asset into production, and by asset, I mean a table, a file, a trained ML model, that's not done in a vacuum. Data must come from somewhere and it must go somewhere. And that means dependencies. And it's the workflow manager or orchestrator that models these dependencies and ensures that the computations that produce data are scheduled and ordered correctly. And even in this example that is on the screen here, this is not a particularly complicated data platform, but as you can see, it has multiple different technologies at play here. Ingest tools like Fivetran coming from SAS, you have Python scraping the web and storing those results in S3, you have the data warehouse, dbt over that data warehouse, you have Census at the bottom, funneling that data back into the SAS products, a BI tool, ML after the data warehouse. There's just a ton going on here. And it's typical at companies that data platforms are more complicated than this. And it's the orchestration layer that's really the beating heart of it. It's a centralized, natural center of gravity for the data platform. In some ways, the orchestrator, because it encodes dependencies between all the tools, it encodes the very structure of the data platform in your org itself. And it also has this sort of beast, nearly an octopus, you would say, the logo, I'm just joking around there, but it grows across your entire organization. It serves a ton of different constituencies, and it's this natural place where all operational stuff happens as well. And really, today's workflow managers really struggle under the weight of this task. They can't handle the complexity. Dev life cycles are slow. It's really difficult to understand what DAGs are doing. And today I'm here to talk about Dagster. And we like to call it a data orchestration platform that is really built for productivity, because we think that productivity is a key underlying problem in data platforms. Everything is just too slow. It's too hard to make change. So I want to dig into this notion of the orchestrator being the central point of gravity. And really, we divide kind of the interactions with the orchestrator in terms of 3 different roles. Role 1 is the data practitioner. And the data practitioner is the person that is responsible for producing data assets for downstream consumers and stakeholders. So a data practitioner could be a data engineer producing Parquet files, an analytics engineer producing tables in a data warehouse, a data scientist producing ML models. Then you have the infrastructure engineers who support all this, and they're responsible for reliable data infrastructure, and they naturally interface with the orchestrator as well. And lastly, you have the asset stakeholders, who are the consumers of data assets. This could be a business user who's interested in the state of a critical data asset from one of these business processes, or it could be a pure practitioner team. And we think it's really critical to serve all of these different stakeholders. So as mentioned in the intro, Airflow is kind of the dominant existing incumbent in the workflow management space. And what we hear from users about that system, as well as other peer systems in the space, is the following. We hear that you can't develop your DAGs locally. It's just a very slow developer lifecycle. Kind of the moment that you hit the orchestrator, you run into this productivity wall. Related to that is that you can't test your DAGs. And testing is kind of the bedrock of productivity, in my opinion, because without tests, you can't have that fast feedback loop. Next, there's all these kind of infrastructure problems with the existing orchestrators. A huge one is dealing with dependency management, meaning that team A wants type Python packages X, Y, and Z. Team B wants Python packages A, B, and C, and they conflict in some way. And it's just very easy to bring down the entire orchestrator. And similarly, these are all kind of a function of the lack of process isolation. It's also kind of difficult to reliably independently deploy code. And last, there's this monitor observe phase. It's difficult to debug DAGs quickly. There's a lack of observability and visibility into the computations inside of them. And you can't keep track of the data assets within the orchestration context. And we think that's critically important, because the whole point of these systems is typically to produce and monitor and observe data assets. And so, as you'll see, we in a deep fundamental way think that the orchestration layer should be data asset aware. So the way we approach this, and as I didn't mention it, but the previous slide chopped up that feedback into 3 parts of the life cycle. We really try to think about the full life cycle in a thoughtful way. So the first phase is development, dev and test. And with Dagster, we want to be able to efficiently and productively build well-structured testable computations. Next, we want to be able to reliably deploy, schedule, and execute those computations. This is kind of table stakes in the orchestration domain. And lastly, we want to be able to track, monitor, and manage asset production. And those words are chosen pretty carefully, because asset production implies that you can monitor both the computations, i.e. the process of producing the assets, and the assets themselves, which is the end goal of these systems. So rest of this presentation, I'm going to go through a demo of a multi-phase data pipeline. You could call it a data platform. And the application here is that we're building a recommendation engine for Hacker News. So we're going to download the data via web API. We're going to use Spark to compact it into Parquet. load it into BigQuery, and then we're actually going to use split that and have a ML team take it out of BigQuery and build a recommendation model using pandas, and now an analytics engineering team use dbt to build analytics dashboards. So let's go through this first phase. So this is kind of a typical task for a data engineering team. We want to download data from the web, do some computation on it, and then load it into BigQuery. And that brings us to the develop and test phase of that. So what's the big problem right now in data orchestration and data platforms more broadly? And we think it's this, which is too often, too many errors are caught way too late in the deployment cycle, meaning that too many errors are caught when the error's on the dashboard, or if you're lucky, in the staging environment. And so the curve looks like this. And the big problem with that is that errors are orders of magnitude more expensive in later stages, right? If the data error gets to your CEO's dashboard, you might get fired, or it might take a really long time to fix it. Whereas if you catch it in local development, that's no big deal, right? Orders of magnitude more expensive in later stages on a few different potential dimensions. And so what's the goal here? We think that a properly engineered orchestrator can bend this curve to make it so that more errors are caught earlier in the developer lifecycle. Now, we're not going to claim that all errors can, because just the nature of this domain, that, you know, data quality tests, a lot of times data quality tests don't pass or fail until you catch them in production, for example. But because of the dynamic that errors are so much more expensive later, this bending of the curve here represents a huge, massive increase in overall productivity of a data organization. Okay, let's actually dig into some code here. So this is Hello World in Dagster, okay? This is how we accomplish this. So we have the notion of a job, which is effectively a graph of computations that is bound to a particular environment. And then we have an op, which is our unit of computation. And then you'll see here at the bottom, you can simply take that job and execute it in process. Very straightforward Python API. We can now dig into a more detailed version of the, well, not detailed version, a more production version of this that actually does a real computation. And you'll see here a few different things. So one is that Dagster thinks about data dependencies, not just execution dependencies. So every single op is a function which ingests some data and produces some data. You know, we think inherently that all data pipelines effectively are graphs of functions, and systems that don't capture parameterization like that are effectively not capturing some of the real underlying complexity and the true nature of what these things are doing. So every node in our graph, every op is a function. The body is completely arbitrary Python. You can do whatever you want. You can do data processing in Python directly, or you can call out to external systems. And lastly, this critical notion of separation of IO and compute. This is the bedrock of our testability and development loop. So you notice here that we output a data frame, which is a logical in-memory construct. We don't output a Parquet file. We don't output a CSV file. We capture how to persist the data frame in a different dimension, what we call IO managers. This allows for a lot of power. You can test these things in memory, and then you can actually shift where things are persisted on a different axis in the code, and we'll go into that. So the moment that you structure your code like this within the Dagster Python framework, you immediately get tools. The first one that you'll use is Dagit, which is our UI in the browser. So all you do is you hop into your terminal, you type Dagit, and boom, you load your pipeline. And you can actually use this tool as almost like a local IDE, which I'm going to show you right now. So we have some code here, which we've loaded up. Oh, and by the way, this is a completely new reskinned, you know, if you go to our website right now, everything looks completely different. On Thursday, we're doing a major new release with completely revamped core APIs and a completely new look and feel. So this is a little preview. Chester has promised not to upload this YouTube video until after that. And I will hold you to that, Chester. But back to the topic at hand, you know, the moment that you put one of these pipelines in this format, you get all this tooling. So for example, this is the code that I was showing you before. And you can see that in the web UI, you can get all these descriptions, which are in code exposed right here. You can see what the inputs and outputs are. You can see where the outputs go, et cetera, et cetera. It's this very rich UI for figuring out what's going on. And what's unique to Dagster is that we render this prior to computation, right? You can see this before anything has been persisted, before you've done any real work. So this makes it super useful. You can kind of understand your system prior to things actually executing. But in Dagster, you can also do more than just view the DAGs. You can execute them locally. So here we have this UI, which allows you to kind of launch ad hoc computations, which ends up being super useful both in development and operational context. Now, I'm going to simulate an error here. So I'm going to go in here and put in an error. Programming. Go back here. I'm going to launch this thing. Okay, and this is going to take a couple seconds, but you'll notice how this is a live updating reactive UI with a live updating Gantt chart. You can get a sense of the performance and whatnot. Down here is a structured event log where you can tell what's going on in the system, and this makes it very searchable and whatnot. And whoop, lo and behold, there's an error here. So I'm going to click on that. And here's this error. It says it's a failure here. You can go and view this full message. You can see it's this nice, well-formatted error message. I can see exactly where the error was, go back and fix it. Go back here. And then I can even just re-execute this single step right here, or I could launch all the computations after that error. And you'll see here, this boots up. And this should take this couple seconds here. And there we go. It now completes. So, if you're a user of, say, Airflow, for example, this type of local rich development loop is just not in the realm of possibility in that system. And it's not because of incidental reasons. It's because of deep philosophical reasons, and then how the system kind of manifests that philosophy. Dagster was built from the ground up to enable just this use case as well as other local testability. And we just got through that demo. So working with an IDE is nice, but you might be an engineer and say to me, that's all cute. I'm never going to use that because I work in unit testing code. Well, that's actually how I feel too. I spend a lot of time in unit testing code. So I want to be able to run this in a CI/CD pipeline. I want to be able to do TDD if that's my thing. And so it's actually super straightforward to, it's really straightforward to call individual ops in your jobs. You simply call them like functions, and that's it. Just that easy. Next, here's just another example to contrast this with Airflow. I know I'm talking about Airflow a lot, but Chester mentioned in the start, so I gotta shoulder into it. The example here is cycle detection. So this chunk of code actually is from a presentation from last year's Airflow Summit, and it showed kind of the code you need to write in order to detect cycles in all your Airflow DAGs. Because Airflow wasn't designed for local development and without flexible Python APIs, you effectively have to re-implement the logic of the scheduler in order to do that. You have to load every DAG, you have to assert, that it's valid, you have to call this undocumented API, et cetera, et cetera. By contrast with Dagster, you simply assert that the job exists, because if it has a cycle, it won't get constructed. Very simple, very straightforward. And we have tons of other examples of places where you catch errors earlier in the life cycle. But I also want to talk about deeper testing, meaning that testing the actual business logic of these DAGs, not just the structure of them. And this is super challenging, actually, because what you really want is to be able to, take your business logic and hold it constant while you change something else about the computation. And we model this desire directly in our abstractions. So we have ops, which are our environment neutral business logic that input and output logical constructs like ints and data frames. And then we have resources, which are responsible for binding that computation to a specific environment. So what I just showed you was a test job that instigated a local Spark cluster on my laptop, and it also persisted information to the file system. But what we want to do is hold that business logic constant and then swap out how the computation occurs. And in this case, it would mean launching an EMR cluster or launching the job on an EMR cluster and persisting the data frames to some format on S3, like a Parquet file. So the way that we do that is through this notion of context and resources. So you can specify what resources an op requires, and then those are attached to a context which is flowed through all of the computations in the system. And it's through this layer of indirection that you can decide how those resources are actually implemented. So in this case, the user has specified a resource called the Hacker News client and provided a test implementation and a prod implementation. And this is what allows me to take the same exact code and run it on my laptop, and as I'm about to show you, run it on a production Kubernetes cluster. And that's where deploy and execute comes in. Okay, so I've kind of framed Dagster as a local development environment, but it's also a production orchestrator that orders computations in prod. And we really designed this ground up for multi-tenancy and for the cloud era. Data platforms are naturally multi-tenant systems, even just internally at a company, meaning like you're both a data science team and a data engineering team that's going to use it. Usually it's way more than that. And the world is cloud native, right? That's the default way that things are computed, and that's how we designed our system. So we have these core components that are deployed. One is the daemon that we call it, effectively the thing that is responsible for scheduling runs. Other thing is the web server, Dagit, which is responsible for observation, monitoring, et cetera. And a critical architecture point about this system is that all interaction with user-defined code happens over a structured API. And this provides for process isolation, which is critical for reliability. So for example, if one of your teams somehow pushed up a Python syntax error, the system just notes that it wasn't able to load the process and everything continues on normally, right? Rather than having a scheduler load those DAGs directly into process and bringing down the entire system, which would happen in Airflow. Our daemon is also designed for fault tolerance based on a reconciliation algorithm. And it provides both time-based scheduling, which we call schedules, meaning that run this on this at this time every single day. And it also provides event-based timing or schedules, which we call sensors, meaning run me every time this S3 bucket gets updated. And then next, we generally structure this so that each run spins up ephemeral computational resources, both for the run and the step level, and then it spins it all down at the end. So this lends itself to dramatically more horizontal scalability and the ability to do things like run them on spot instances for cost. So this is very much designed for the cloud. And then all this is customizable and pluggable so that you can run it on your infrastructure, and it has a lot of flexibility, but we also come with an out of the box production grade Kubernetes deployment. So we have a very flexible, nice Helm chart. So what does this look like? Well, I'm going to hop to a different web UI. You'll see this is at demo.elemental.show. And this looks very, very similar to what I just showed you. The difference here is that this is the same kind of set of ops bound to a different set of resources. And that's just a code question. And now I can launch this. And instead of just launching a local little process on my computer, as you can see down here, this is actually spinning up a run worker, a Kubernetes. Run worker is our concept. It's spinning up a Kubernetes pod. There's a run worker inside it. And now it's kicking off these computations. This is hitting the public Hacker News API instead of a local test snapshot. Every single step here is booted in its own Kubernetes pod for process isolation. So all this infrastructure stuff has changed, but the business logic has been held constant. And that is really the critical component to testability. And I'll be spending a little more time in this UI as time goes on. Let me go back to here. So we've deployed the computations and we've kicked off a computation in prod while holding the business logic constant. And now let's talk about the monitor and observe part of the lifecycle. And what we're going to do, how we're going to do this is we're going to add data science. So the computation I just kicked off ad hoc. What it did is it kicked off a Spark job, effective downloaded stuff. It kicked off the Spark job to compact it into Parquet and then load it into BigQuery. Now we want a different team to fetch that data out of BigQuery and use it to build a recommendation model. Before we get into the details of that, I want to step back and think about how a data platform wants to think about the different roles that it serves. And the way that we think data platforms should think about it is that there's this full life cycle, and every single stakeholder has this full life cycle, meaning every practitioner stakeholder. They develop an asset, they need to monitor it. You want to enable end-to-end ownership. And really the job of a data platform engineer is to fill in all of the boxes here so that each role has its own end-to-end life cycle. So, you want a uniform surface for both deployment execution and monitor observation, right? You should be able to use this unified substrate there. And then the different practitioners can focus on their business logic using the tool of their choice. So a data scientist just wants to write Python, right? Maybe they just want to use scikit-learn, pandas, et cetera. They want to be able to leverage infrastructure built by the data engineers, and that's great. But they still want to but in the end, the goal here is to be able to focus on business logic and a tool of your choice. So we're thinking a little bit, we're building a recommendation engine that typically takes a DAG of computation. And this is how you do that in Dagster. So each one of these nodes in this graph is an op. And you can see here that you construct the graph that the job contains by calling functions, right? And this doesn't actually instate the computation. This actually just builds that dependency tree. And the actual bodies of those functions are invoked later. So this is what the world of Dagster looks like to a data science user. And it's just plain old Python, right? You might not know what truncated svd.fit does, but data scientists do. So they're just using the plain old Python they know, love, or tolerate. But you can add some sugar with Dagster, and allows you to attach metadata to all these different events, both the kind of software artifacts as well as the persistent events. And this allows a lot of power in this. So the way this is configured is that every single step in this pipeline, every single op produces what we call an asset. An asset has specific meaning in the world of Dagster. So an asset is an entity that outlives a computation, right? Producing assets is effectively the entire goal of these systems. So an asset could be a data warehouse table. It could be a Parquet file in a data lake. It could be a pickled model. And it's been really powerful, both for us as dog fooders, meaning using our own technology, as well as our user base, to really embrace this concept, because operationally, we have this, what we think is like a critical insight, which is obvious in retrospect, but people care about assets. They don't care about pipelines. I hate to break it to you, the data engineer, but if you go talk to a business stakeholder, they don't care about your pipeline. No one cares. They only care about the assets that you produce. And this way of thinking, if you fully embrace it, is really, really empowering. One great quote from a favorite user of ours, David Wallace, who's a staff engineer, now at Dutchy, previously Drizzly, is that Dagster empowers my stakeholder teams to own their data assets end-to-end like no other orchestrator can, right? And that's specifically because of this philosophical view that we take, that assets should be part of the game. So if we go back to this, let me go back to the prod. So this thing has, so this is finished as computation. And we have this structured event log down here. So, Dagster computations emit this stream of structured events, which tell the system what is going on. And one of those events that the user emits is what we call an asset materialization. So see how nice and fast it UI is, whatnot. These are actually events which say, hey, I produced a specific materialization. It's going to outlive the compute, and I'm going to attach metadata to it. Well, the interesting thing about that is that we keep track of that in what we call the asset catalog. So if you go and view this asset, right, here's this items asset, right? And this is what, an S3 file that contains the items that were produced by something. And you can see here, we have all this interesting metadata about what's going on here. We have the row count, which goes up and down over time. We have the step execution time, which has gone up recently. That's interesting. And so that's useful too. But where this gets really interesting in my view is that this allows a completely new way to index into the information encoded by the orchestrator. So let's pretend like we're some stakeholder and we know there's a comments table in the data warehouse. Now I can just go to Dagster, right, and search for that thing. Let's see, comments. And actually, we're in Snowflake now, not BigQuery. We actually ported it. I need to move the slides. But let's go to here. Look, we can find the Hacker News comments table, right, and search for it. See its properties, and then we can see, oh, this was produced by this Hacker News API download pipeline. The last time it was touched was at 1:31, 6 minutes ago. It was touched by this run. So you can navigate back and forth from the computations to the assets back to the computations. And this is a super powerful way to navigate and operationalize your data systems. Go back here. Assets are not just useful to track. They also have really useful properties, is that there's a great way to encode the dependencies between teams. You might be familiar with the concept of the data mesh, which is kind of all the rage. But I think the most powerful and interesting idea out of the data mesh is that assets should be the interface between teams. And our system encodes that directly. So in this case, we have one data science job. It's kind of in the abstract downstream from the data engineering job. And the way we hook those two together is through what we call a sensor asset key, or asset sensor. And so all this says is that anytime an asset is updated, kick off a new job. And so if I go here, let's go to the store recommender, and we go to the sensor here. You'll notice here's this live updating page, and all these dots represent the last time that I checked to see if the asset key has been updated. My demo took a little longer, so I need to go back to this 1 day view. And you'll see that, okay, a job was kicked off, a run was kicked off at 1:32, which is, happened right after that ad hoc job I had kicked off had just completed. And we can go here and click on this, and then you get all the exact tooling that you're used to, right? So I can go here, check out what the asset materializations are, and I can see what's been going on here. And this ends up being a super powerful operating modality for data platforms. Even as we were developing this internally, the person, I think it was a couple of people actually, who built the data science job told me, hey, I didn't need to know anything about their pipeline. All we did is we agreed upon a mutually agreed asset key at the very beginning of development. It's like, you're going to produce this table. I'm going to consume that table. After that, we live in different worlds. And that's a super powerful way of operating. So that's kind of the life of a data scientist in this system. I'm just going to quickly go over what the workflow of an analytics engineer looks like. And if you're not familiar with the term, analytics engineer is effectively a term invented because a technology called DBT exists. And you can think of DBT as a way that you make an analyst into an engineer, an analytics engineer. It's a super powerful tool. So if you're a if you're an analytics engineer and you're listening to this presentation up until now, you might hear develop and test and be like, oh, the orchestrator is going to take over my develop and test part of my life cycle. Well, I don't want that because I use DBT. I like DBT a lot. I like to talk about how much I like DBT a lot. And I have no interest in abandoning that tool. And we totally agree with you. We fundamentally believe that people should use the tools they want to do data processing and that the orchestrator should facilitate that. And so in this case, we have a fully functioning DBT integration that integrates very nicely with the system. So this is what it looks like to develop DBT in our system. It takes very few lines of code, and then you can just run an existing DBT job. But when you do that, you get all these integrated capabilities of asset tracking and whatnot. So if we just go quick back here, DBT metrics, this is a very straightforward DAG. All it does is invoke DBT run and DBT test. But if you go here, this one is kicked off at, oh, the sensor is off. How sad, I messed that up. But if the sensor had been on, you would have seen one running about 10 minutes ago. But, just like our other tools, we can go to the run that I did last night. And just like the other, one of the built-in capabilities we have is the ability to produce asset materializations as a result of a DBT run. We ingest the metadata that comes out of DBT and persist it in our system. So this allows Dagster to be the single operational pane of glass where you can manage all your assets and computations, no matter what tools they end up being computed in or stored in. And that's extremely, extremely powerful. So to sum up here, we think that orchestration is a point of leverage, both for you as a practitioner or a platform engineer, but also for broad ecosystem progress, meaning that the ecosystem is incredibly fragmented and difficult to navigate. And the orchestration layer is really where all this stuff has to come together. All the tools, all the practitioners, all the storage systems. So we think it's a massive point of leverage for improvement. We embrace the full life cycle, and we think this is key to having a productive data platform. We fully considered developing and testing in this system, deploying and executing the computations, and monitoring and observing both the computations and the produced assets. And this enables a really fast developer workflow and end-to-end ownership, which means dramatic increases both in individual productivity and organizational productivity. And it's an open source Python framework. You can end this presentation, sign off, and go and install it for free. As per an open source project, you can check us out on GitHub. We have our docs, and then we have our Slack, which is very active and the best place to go to interact with our community. And like I mentioned, this is actually the first presentation we've given with our updated look and feel, our updated core APIs, and our release of this is on Thursday. And it's probably the biggest release since the initial release of the project. So we're super excited about that. And without further ado, I will take questions.
Great talk, Nick. So I'll wait for your instructions of when I can make the So
well, you'll send me the video, and then I'll see if it's good, and then I'll decide when we'll push it out. No, okay. I'm just kidding. Well,
let me ask you. This is a very interesting topic because echo some of the stuff we do on my team. Frankly, we did build our own dev, separation of dev, staging, and productions, and we have our own, testing environments for our workflow engines, and try to, without changing the code, but it can run in different environments. So it's very interesting to see Dagster how it's done. I do have a question on one of the pieces that you mentioned that, and also interesting. So the Dagster actually interconnected with this asset categories catalogs, which literally almost like another system similar to the data cataloging which you can discover what table you have or what metadata you have and what's the min max, that sort of thing. So it seems like a Dagster actually bundled that together. In other words, this probably is something like Amazon, like the open source Amazon projects, kind of embedded in the Dagster itself. Is that correct?
So we like to call our asset catalog an operational asset catalog. So it's mostly for operational use cases. And so we really focus on use cases that we think make sense. We can get a lot of benefit with vertical integration with the orchestration layer. So the most obvious one is like a direct linkage to the run that produced the asset and be able to click that really easily, being able to set that up without integrating yet another tool, right? Our goal is not to replace all the asset catalogs out there. There's like tons of companies who are devoted to that. They often have asset catalogs that are also scraping for information that was like manually created. They have manual annotation systems. They're and have more complicated ontologies. What we wanted to do is one, provide a built-in data asset catalog for simple use cases that people get out of the box. Mm-hmm. And then two, be able to leverage it for operational use cases where it really makes sense to integrate it with the orchestrator. And you'll continue to see us double down in that direction. Fully plan on having, our metadata database, you can query it yourself and ingest it, and we produce a structured event stream. And so we fully expect that to produce exhaust that would be consumed by the likes of Data Hub or Stemma / Emunson, et cetera, et cetera. But we think it'll be a really valuable source of metadata for those systems.
Yeah, I can see that. But it seems like a majority of the company's data results is actually produced through the orchestration workflow engines. So there'll be a big chunk coming from here, I guess.
Correct. Yeah, but the lots of companies will have many different orchestrators. Teams making their own decisions about stuff. So we don't have any illusions that we're going to be the one asset catalog to rule them all anytime soon. Nor do we want to cover like a lot of the use cases that I covered.
Got it. So there's a few questions in the chat. Let me just read through them. So, okay. So one from Dave says, what are the examples of the companies and application areas that have complicated data dependency graphs and would benefit from Dagster?
I think the real answer is nearly every company. We like to say that every company has a data platform. It's a question of whether you acknowledge it or not. Because if you don't acknowledge it and staff it, it exists, but it becomes this complete unorganized mess that's not operationalized or well engineered. And what a data platform is where you manage and curate all of the data assets of your org, meaning the data has been ripped out of its original context, whether it's a SaaS app, one of your operational databases / system of record, or like scraped from the web or something. And so anytime that you are doing that and you're stitching together more than one, say, computational runtime, and you need operational robustness around that, you need something like Dagster. And at that point, it's kind of like, it's the type of thing where like, if you're going to build something, you want to do it right. So it's, to me, if you don't use something like Dagster, it's kind of like saying when you start writing a computer program, it's like, oh, I'm just going to write some code. I'm going to refactor it into functions later. It's like, no, you just want to start like engineering it properly from day zero in order to build a well-structured system where the entropy isn't going to get out of control. So, most companies I know of require a system like this because they need to ingest data from SaaS apps. They need to integrate those. They need to compute data that resides in their data warehouse, and then they need to do something with that. And even in the simplest cases of that, you need an orchestrator to make that all work well and reliably.
So next question is, this one is a great demo. And he want to know, can you share integration to Databricks?
Well, we do have a Databricks integration. So if you go to our open source repo, there's Dagster Databricks. So we have a built-in integration for that.
Great. Next one is asking your business model. So how do you make money?
How do we make money? So it's a good question. We are a venture-backed company. And so there's an expectation of, a sustainable business at some point. And I also think that's the right way to sustain a open source project, but that is a entirely different talk. Concretely, you can sign up for Dagster Cloud right now. So we are building a SaaS product. We will be opening that up to a more publicized early access in a few weeks. But if you go to Dagster.io, there's a cloud button. You can click on it and then sign up. And what that involves is that we host a bunch of the services that make Dagster work. And while allowing you to retain control over your code and data. So this is kind of the, now more broadly used so-called hybrid SaaS model by the likes of BuildKite and Databricks. And we handle upgrades for you, maintain the performance of the metadata database, the web server, we handle all upgrades, and so on and so forth. And then we also add enterprise features like authentication, RBAC, auditing, and a bunch of CI/CD help. So Dagster Cloud will be our short-term path to monetization and a sustainable business.
So in the hybrid cloud, is essentially you're using the account of the clients and then build on their, say, for example, the AWS, you're just using an AWS account and directly use their EC2 instances, and but you have a control plane to decide.
Correct. We manage the control plane, and the data plane is in the customer VPC.
Okay. Yeah.
And there's no ingress into their VPC. There's an agent that phones home over HTTP.
Yeah, I think that clear a lot of the people has the security concerns and all the other concerns with the company.
Yep.
Right. So I think that's let me see what's the last one. So so needed agree with the ideas and the interface should be assets. So this is just a comment. So somebody,
I would call it an affirmation rather than a question. Very much appreciated, Linda.
I think that's pretty much all the questions. So anybody has other questions, if you want to ask, go ahead, ask. We have a few more minutes. Which cloud provider will Dagster use? This is coming from Dave.
Yeah, well, Dagster is actively used on all the major cloud providers. And Dagster Cloud is itself hosted on AWS, if you're asking about that. But that's actually very opaque to you. But Dagster is flexible enough to use in any cloud provider as well as even on-prem.
Cool. So how big is your team? If I recall, there's one of my old acquaintances from Cloudera. I remember somebody from Cloudera joining your team. If I don't remember,
you're probably referring to Sandy. Yes, one of
Sandy,
Sandy Rizza. Yes, very talented. He leads our practitioner team, which is responsible for most of the open source practitioner facing APIs. And so yeah, no, we have a team of 18 people, including me, and we are actively hiring. Head of product, DevRel, a tech writer, and also engineers. So if you're interested in joining the team, let me know. My DMs are open on Twitter. Or anyone can hop in our Slack. If you want to find out more about the system, hop into Slack.
Okay. We got a kind of one more question. Actually, two more questions. So kind of related. So do we have an SDK to get a job dependency lineage to integrate it with the Amazon or Data Hub?
That does not exist. We're not opposed to building it or having a community contribution, but it just hasn't come up actually. So we build and support integrations based on demand, but we're philosophically very open to it, as I mentioned.
And ops follows that and say, is there an SDK for plugin to integrate with the downstream systems?
So yes, if you go in our open source repo, you can see all the different libraries that have been built. And then there's also libraries out there in the wild too, in terms of, something we need to do is build a catalog of those. But yeah, no, one of the advantages of an open source system is that one, you can see all the integrations, and then often those are community contributed, which is great.
Great. I think that's all the questions from the audience. And I'd like to thank Nick again for great talks and introduce the Dagster to the, to our communities. Yeah, we'll hope to welcome you coming back in the next time to give more insights on the Dagster.
Thanks, Chester. Thanks for having me. And thanks for everyone for all the great questions.
Thank you, everybody, to join the San Francisco Big Analytics. Thanks, AI Camp again for providing the Zooms. And we'll see you next time.